Welcome back everybody to another tutorial with Charming Data. In this channel, we specialize in data visualization in Python. So this week we're going to focus on the box plot and the violin plot. You're going to learn all about the two different plots. You're going to learn how to create this kind of plots. We're going to create various types of plots. We're going to create plots that violin plots that compare between each other. We're going to do a horizontal violin plot. We'll also add some dots, which is also called a jitter plot next to the violin plot, so you can see density. We'll compare between groups of states in this case. You'll do also an overlay, so it's easier to compare. We'll also learn how to change the colors according to the colors that we want, how to change the hover of the jitter plot, so you can also see all this text inside the hover and change that text. We'll also look how to create in different rows and create our violin plots in columns. We'll also look at the template, so we can change the template in the background and other things in the template. Also an animation, so you see how every year the violin plots will change, so that's a nice comparison over time. And lastly, we will look into a challenge that we're going to do in order to that you're going to do on your own in order to solve this and learn more. But before we go into the code, I want to explain a little bit about the violin plot and the box plot for those who are not very familiar with these graphs and all the numbers that they represent. If you already know about this, just fast forward this video about 2 minutes into the future and we'll go into the code that shows you how to plot all these violin plots that I showed you before. Okay, so a little bit about the numbers. Let's zoom in here a little bit. Okay, so the violin plot is built from a box plot together with the violin plot on the outside. Box plot is going to give you these numbers that you see in red. So it's going to give you the minimum on your bottom right. You'll see disease minimum is 0.8. In this case, it's 0.8% of colonies are impacted by this disease, bee colonies. And then you'll see on the left, you'll see Q1, median, mean, and Q3, and upper fence. What do these mean? The box plot is typically divided into 4 different groups with 3 points. And these 3 points are quartile 1, quartile 2, and quartile 3. And that gives you 4 different groups in the box plot. So the first group is between minimum, which is 0.8, to quartile 1, which is 2.92. The second group is between quartile 1 to the median. The third group is between the median and the quartile 3. And the fourth group is between quartile 3 to the upper fence, which is also called the upper whisker. So anything above the upper whisker is considered an outlier. In this case, we have one outlier, which is on the top left, a disease max. 42.3% of the bees colonies were affected by this disease in Idaho between January and March. So this is an outlier. This shouldn't happen very often. So that's the box plot, and those are the numbers for the box plot. A violin plot that encompasses and goes around the box plot is actually a way to depict distribution of numerical data points. So in this case, we see that the distribution of most of the points is going to lie somewhere around here. You see all these points here, but most of them, the highest density is around this, between 0 to 10 or 0 to 5. This is also called, as you can see here, a KDE, which is a kernel density estimate, just a way to estimate the distribution of points. So in this case, the thickest one, you see how here is the thickest, from here all the way to here is the thickest part of the violin. This means that is where the highest density of points appear, which means that in the future, under similar conditions, similar weather conditions, and similar diseases, and similar bees colonies, most likely there will be anywhere from 2 to 5% of bee colonies affected by this disease, because this is the thickest part. So if you want to learn more about the KDE and the violin plot and the box plot, I would recommend going here, open this link underneath the video, and you will see all about the box plot, which goes over what we just went over. See the quartile and and the whiskers and the outliers, and gives a nice explanation. And here, the second link is about the violin plots. So it'll teach you all about the violin plots and the distribution and the KDE and what each one of these things mean. Okay, so the code. This is the code that we're going to use. Open it under the video, open the link of the code so you can follow along. The data that I use for this code comes from the National Agriculture Statistics Services. So I saved this this link for you. If you want to create the same Excel sheet, this is how you create it. These are the categories that you should use, and under here, and you'll be able to create the same Excel sheet. Just click on Get Data, or just click on the link below the video, and you'll have access to this Excel sheet, which we're going to use in the code. Value, state, we're going to use all these columns. Value is the percent of bee colonies that are affected by whatever, the disease or unknown cases or by different things. All right. Did I miss anything? No, we're good. Okay, and we're gonna build the code with Plotly Express. Plotly Express is right here. Open this link below. It teaches you all about the violin plot and different things you can do with it. And these are the parameters. This is another link that we're actually going to learn today inside the violin plot. All these parameters we're going to learn how to tackle and how to best use in order to create all these plots that we created. Okay. So let's get right into it. Get some coffee because I'm dying of thirst. Okay, so the first thing you want to do is import these libraries because this is what we're going to use. The second thing is between here and here, this section is to import the data and to filter it. So we're going to import the bees.csv data. I'm going to change the value to numeric because I think it's text on the Excel sheet. And then I'm just going to change the data item column. I'm just going to change the values because these are long strings and I don't want all these strings. I'm just going to name them differently. Disease, other, pesticides, just different names. Okay, and then I'm going to map it so it changes. And then I'm going to rename the column. Instead of data item, I'm going to call it affected by. So what are the bees affected by? And the value is actually the percent of colonies impacted. Okay, and then I'm going to print it out. And here I go into building the violin plot. So it's anyway, we're going to go over all the parameters one by one or section by section. And then we're going to up until here, close it, and then we're going to print it out. All right, so let's see how we are creating the first plot. Okay, so the first plot is this, all the way to the left, and this is a normal violin plot that has an x-axis of the diseases or things that are impacting bees, and then the percent of colonies that are impacted. From 2015 to 2019, it puts all the data together. Okay, so in this case, we're just going to say the data frame is the data frame, the DF, that we're using here that we filtered. The x-axis is going to be what they're affected by. Remember, we already changed the column names right here, so we can use affected by. And the y-axis is the percent of colonies impacted. Orientation is going to be vertical, and the category orders are this. I want to put this order. This is a parameter in the violin method that can change, that allows you to change the order of anything. So I'm going to change the order of this column, and the order of this column, the row data is going to be this order. Okay, so by doing that and clicking on show, I get this plot. See, with this order, disease unknown. So you can see I try to order in a way that it goes up. The most disease that affects the bees the most is varroa mites. I wonder how you even pronounce that in English. And you see the median is 26.9, and the max is like 98% of the bee colonies were affected at some point by these varroa mites in the U.S. in a certain state. Okay, so the next plot we're going to create is horizontal plot. To create that, all you have to do to create the horizontal plot is go, instead of V, change that to H, because H means horizontal. And you want to change the x-axis and the y-axis, because obviously you're doing it differently. So I'm going to copy this here. I'm going to affected by, and the x-axis is going to be this. Save it, run it, and this is what you're going to get. All right. The next plot is we're going to create all the jitter plot right next to it that shows you all the dots. Obviously, if you have like a million dots, this is not going to be very effective, but if it's a couple hundred or 1,000, it should be fine. So we're going to add this, and we're going to add the box plot inside the violin. So to do that, let's just Control Z, Control Z, Control Z, back to vertical. Okay, so to do that, just points go all, and box equals true. Box parameter has true or false. We're going to do that true. And the points has outliers, suspect outliers, all or false. You want to read more about it, go into the link that is below the video, and you'll see under points, where is points here? Points, 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 where are your points here? Here are the options that you have under points, and it explains what each parameter or argument within the parameter means. Outliers is by default, false is none, and sub-outliers is just another part of the outliers. In this case, I want to put all. You see, this is what we changed, and you run that script and you will get this beautiful plots. Okay. I really like this density jitter plot because I can see visually how all the dots really concentrate here, which is why this is the thickest part of the violin plot at 0.741 kernel density estimate, highest probability. Okay, the next plot is we're going to compare between two states and using grouping. So to do that, let me see. I'm going to take this out, hashtag this out, and I'm going to do color state. And I'm going to use, instead of overlay, I'm going to use group. I think group is by default the case. And I'm going to hashtag data frame out and use this data frame query, where it queries the state that I'm going to use. And the states that I'm going to use in this data frame are Alabama and New York. So if you run this, you will get this plot. All right, you see how New York is orange and Alabama is blue. Now you can control the color. You can say, well, I don't want them to be this color, which is the default color in Plotly. You can say, I want the color to be lime green and red. Right? And if you do that and run the script now, then you will get, oh, sorry, even before the colors. So the lime green and red is this. You got the colors here. But one thing I wanted to show you before you change the colors is how to, you can do an overlay. So instead of grouping them together, comparing one by one near the other, you can do overlay, which is just changing this. So just change this to overlay, and that would actually create this plot, which is kind of cool because it's easier to compare. Look at this. New York and Alabama, so you can see that New York, bee colonies affected by disease, really there's a thick amount of, this is the thickest part of the violin, so what's the median here? The median is 4.5, while in Alabama, the median is 0.2. So in Alabama, like very few bee colonies are affected by diseases compared to New York. Great. Okay, so we created an overlay. This is the color that I showed you a second ago. You can do it this way, or you can do color discrete map, where you can tell, just hashtag this out. You can tell the app, the web app, what each state color, which color each state is going to be. So in this case, I'm going to use this. All right. Hashtag this out. Let's look at the next plot we're going to create. This is where we're going to control the hover. So you see how there's 2018 and different text inside the hover. To do that, all you have to do, we don't have state anymore. We don't have overlay. We do have points. So we're going to do this. We don't need state. This is how it's going to look like that, and just change the hover to year, state, and program. Yes, year, state, and program. Okay, so if you run this, let's try to run it just in case to make sure I'm not missing anything. So if you run this, you will get this plot. Let's double check. It's creating a new plot right now as we speak. Yes, this is the plot that we wanted. I just focused on pesticides, so let's focus on pesticides. Perfect. So this is the plot. So you see, when you hover, you'll see that the year is on top because we put here hover name is year, and this means that the bolded part is going to be on top. And then the state is going to be somewhere in the middle inside the tooltip hover. So you see there's affected by, which is the x-axis, the y-axis is the percent of colonies. That's always going to be there because by default we plotted the x and y-axis, but I wanted it to add the state, and here you can see that it's Arkansas and all the other states that are affected. These are outliers, so it's kind of cool to see the states of the outliers. So the next plot we're going to do it over, we're going to create rows. So to create rows, what you have to do is, I forgot to mention custom data. This allows you, this is invisible, you can't see it on the plot, but it allows you to use this data as part of callback and Dash. So if you go into Dash or you use Dash to create interactive data visualizations or interactive graphs, you can have access to the program. Let's call it period. The program doesn't mean anything because there is no program column. Let's call the column period because we do have, right here you'll see we have a period column, January through March and so on and so on. So now I have access to this data if I need access to it when the user changes something. A little bit complicated. If you want to go more into Dash, just look at the different videos that I have about interactive Plotly graphs, and you'll learn more about this custom data and how to use it. Hashtag this out. Okay, so we're going to create rows. So we're going to create rows based on state. Is that what we wanted to do? Yes, state Alabama and New York. So hashtag this back in state. Make sure you change, let's not do all, we don't need this anymore. Make sure you activate this again because we just want Alabama, New York, and deactivate this. You don't need 2 data frames, that will break it, doesn't make sense. And then just run the script and you will have this plot. That's plotted on 2 separate rows. Alabama's one row and New York is another row. And if you focus on them, you'll see that you can zoom in. Perfect. Now we want to create columns. To create columns, here I'm saying create 2 columns, but on 2 separate rows. To do that, all you have to do is say, hashtag this out, is say this. I'm going to create 2 different columns that are categorized by period, and they're going to divide it up into 2 different rows, right? Or just divide it up into 2. But because we have 4 different periods, 1, 2, 3, and 4, it divides up into 2 different rows. Play around with it, add different rows if you want, or divide up different, use a facet call, use a different value here and see how it divides differently. All right, hashtag this out. One thing you can do is also log. Log X doesn't make sense here, but log Y. This would allow you to create or to visualize plots that have really big outliers where data points are at the extreme. In this case, it doesn't make sense. It's not needed, and it just kind of confuses you. You see, this is logarithm base 2, I think, and it will log data points that are very, very high up. But in this case, you don't really need it because everything is pretty small. So let's erase this. Okay. So the next plot we're going to look at is how to play around with the template. To do that, let's hashtag this out. Again, this is what we have on top. So all you need is this, and we're going to say that the labels, we're going to change the labels from state to capitalized state. That's going to be the legend. And let me add the color here. We need to add color state. And the title we're going to give it is this. We're going to control the width and the height of the plot. And we're going to say that presentation, the template is not going to be presentation. It's going to be Plotly dark. You can choose any other theme that you want. And if you save it like this, this is what you're going to get. Okay. Oh, actually, I didn't divide it by color here. So there is no color agenda. This is only one set of Plotly violins. So to do this, you just keep it this way and just hashtag out state, and that's it. I mean, you can even hashtag this out, hashtag this back in, and this is how you would create that same plot, okay, because there's no state in there. But play around with it, create different plots that you want. Okay, animations. To create this animation of plots, what you can with the Violin plot, what you need to do is leave this all the same, data frame affected by categories and orientation. And then I think all you need to do, let's see if I can remember this correctly, is, let's change this back to presentation. And animation, go to animation year because you're going to do it by year. Select the range of the Y that you want. It helps the graph to be less bouncy. So I know that the range of the Y is going to be anywhere from -5 to 100 because no data point is above 100 and no data point is below 0, I think, so just in case. And category orders, I want the order to be this way because the original order is from 2019 down to 2015, but I want to change it. I want the animation to go from 15 all the way up to 2019. Don't forget, because you're doing this, go back up here and unclick hashtag this out because you can't have two category orders in the same Violin plot. So hashtag this out, hashtag this back in. Also hashtag this in. You don't need this. Hashtag this in, and you will have control over the transition or the duration from year to year is going to be 1000 milliseconds, which is 1 second between year to year. So if you save this and if you run it, you should get the exact same plot, or we should get the exact same plot as this. Let's make sure that we get it so I'm not confusing you. Drink some coffee in the meantime. Perfect, we got it. So you can see now that we click the animation, every year there's going to be 1 second of time lapse between year to year, and you can see how the Violin plots are comparing and changing between year to year. It's a cool animation, and you can create very cool ones with other plots as well, since now I've taught you how to create this animation. Wonderful. So we just learned about the Violin plot and the box plot and all the different ways we can play around with those two plots. Click on the poll above. Next week or in 2 weeks from now, I want to create a tutorial on a different graph. I would love to hear from you which graph you would like to see next, and I'll try and create the one that most people want. Don't forget to hit the like button. Don't forget to subscribe below and turn on your notifications for this channel. So every week you can get a video or two on different ways to create different plots, different graphs, different interactive charts, and different ways of creating your own web apps in Python. All right, guys. So what I'd like you to do, ladies and gentlemen, is to build a plot that compares impact of disease on Idaho and Texas bee colonies with box plots and the blue mean line. And I want you to use colors lime green and red for each state and add all the points and period to the hover data. So what this means is you're going to create this different plot. So you see there's points on the side, there is the mean data in the blue dash that represents the mean data. It compares Idaho and Texas, disease only. I'm not comparing other things, I'm only comparing disease and how it affects the percent of colonies impacted over the last 4 years, all bundled up together. So good luck with it. Try it on your own. I do have the solution, and I'm going to put the solution in the comments, in the first comment. But make sure that you try this on your own because it'll give you a chance to practice the data and practice using Plotly and making these beautiful graphs. I hope you enjoyed. Have a good day and stay strong.